So I'm actually recording this right now. We've already gone through the first three rules of exponents, and we're going to move through the last four rules, right? Let's review the first three. Rule number one, that's when you had something to a certain power times something to a certain power, but you had the same base, right? When you have the same base and you're multiplying, what do you do with those exponents? You add them. So x to the second to the third, what is it? X to the fifth. You simply add them. That's right. Rule one is adding exponents when you're multiplying two terms with the same base, or multiplying terms with the same base. Rule number two, in case you forgot from yesterday, when you have a power to a power, what do? Multiply. So x to the second to the third, we end up with x to the sixth. Rule number three from yesterday is when you have parentheses and a monomial on the inside, no addition, no subtraction. Like let's say I had a 2x to the second, y, z to the fifth to the third power. Then you distribute the outside exponent to each exponent on the inside. Okay? So this is not a 3 times 2. It's not. There's an invisible 1 up here, and that's a power to a power. That's what you multiply. 3 times 1 is 3. So you're going to start out with your answer 2 to the third. And then the power to the power of 2, power to a power multiply. That's what rule 2 says. 3 times 2 is 6. So you're going to get x to the sixth. And then you have y, and y to the 3 times 1, the invisible 1, is 3. So y to the third. And 3 times 5 is 15 on the z. So we get z to the 15th power. That was rule 3. What do you think? Easy peasy? I hope so. Now rule 4 is the same exact thing as rule 3. Okay, so in reality, we're not going to learn another rule at this moment. Rule 4 is the same thing. Well, I'm not a power 4. Let's keep it a power of 3. Why not? And on the inside, maybe instead of what we had up here, maybe on the inside we have something like a 2x squared over y to the third z, right? And what you do there is the same exact thing. You distribute 3, put it on the 2, put it on there, put it on there, put it on there, and your answer will be 2 to the third, x to the sixth over y, 3 times 3 is 9, and z, 1 times 3 is 3. Same exact rule as rule 3. Does that make sense? I know I rushed it right there. Oh yeah, and other things, I apologize. Like let's say we look at number 3 again, and this was our final answer. You should actually do this math. 2 times 2 times 2. That way this would be an 8. Same thing here. 2 to the third is really 2 times 2 is 4 times 2 is 8. So you'd put an 8 on your final answer instead of 2 to the third. But anyway, we're going to begin today's rules, or set of rules, with this one, number 4, which is the same thing as 3. Whenever you have parentheses with an exponent on the outside, distribute that outside exponent to each exponent on the inside, and of course a power to a power multiply. That's why on the handout that I'll give you later, you're going to see rules 3 and 4 together, because it doesn't matter if you're distributing to each term right there or distributing into a fraction. As long as there's no addition or subtraction, you're able to do this. All right? So I don't know, if you're writing these rules down, I would write down rule 4, and I would write down same as rule 3. And what is that rule 3? That you distribute from the outside to the each inside. Okay? So rules 3 and 4 is all about distributing the outside exponent to the inside. Now, these two examples are shown to us. They actually have the final answer here, let's take a look at some that you don't see the answer to. How about these two right here? Do we have parentheses? Yes. We actually did this yesterday on rule 3, right? Whenever you have parentheses with an exponent on the outside, you distribute it. That'll be 2 to the third. Distribute it. That'll be x to the sixth. You guys got that? So it's that simple. Again, we did this yesterday. 2 to the third, x to the sixth. Final answer, to write the best answer, that'd be 2 times 2 times 2, which is 8, x to the sixth. Anyways, we did that yesterday. Let's jump into something that we haven't seen, something that we just did a little while ago. This is rule 4, where you're still distributing, but you have a fraction to distribute it into. So everybody copy down number 3. Again, 1 and 2 we already did yesterday. Let's move this out of the way. It's all copied down number 3 right here. And again, anytime you have parentheses with an exponent on the outside, you're going to distribute that outside exponent to each and every exponent on the inside. And of course, a power to a power, you multiply. So this 3, you're going to distribute it to the power of 2, and a power to a power, you're going to multiply. So up on top, you're going to have x to the what? 6. Thank you very much. And then we're going to take the 3 and distribute it to the 4, and a power to a power, you multiply. So we're going to have z to the what? 12. That's right. And we're also going to, let's not forget to distribute it to the actual number 2 that has an invisible 1 right there. So this is not 3 times 2. This is 3 times 1, and then you're going to have 2 to the 3rd, right? So right here you're going to have 2 to the 3rd, and we might as well write down 2 to the 3rd. What is 2 to the 3rd really? 8. Okay, so you might as well write down 8. We ended up with 2 to the 3rd, and that's how we got the 8 right there. And last but not least, distribute that 3 to the power of 5, power to a power, multiply, so we end up with y to the 15th. And that's it. What do you think? Easy? It's actually the same rule as rule 3. Rule 3 is rule 4, right? Just distribute the outside exponent to the inside. The only time you cannot do this is if you had like addition between the x squared and the z. Like if you had a plus sign right here or a minus sign, you can't distribute. You just can't do it. But on all of these, on this section, you're not going to have any addition or subtraction. You're going to be able to distribute. All right. So I hope we're cool with rule 4. Let's move on to rule 5, my favorite rule, the easiest rule. Check it out. Everybody jot down rule number 5, and then write down the sentence, anything to the power of 0 equals 1. And here's your first example, x to the power of 0, that equals 1. Anything to the power of 0 equals 1. I'm just going to freestyle right here. 5 to the power of 0, what does that equal? 1. Y to the power of 0, what does that equal? 1. Let's say 258 to the power of 0, what does that equal? 1. Okay, what if I said, what is 2x to the power of 0, what does that equal?
1.
Curveball. It's not 1, it's 2, right? Okay, now here's the deal. What does the rule say? Anything to the 0 power equals 1. What has the power of 0? The x has the power of 0, right? The 2 actually has an invisible 1 right there. So 2 does not have the power of 0. Only the x has the power of 0. So when you think about PEMDAS, what do you do first? Do you multiply first, or do you deal with exponents first on PEMDAS? Exponents first. So x to the 0, that really applies the rule that anything to the power of 0 equals 1. And then there's multiplication between the 2 and that answer. So 2 times 1 equals 2. So that's the only tricky part about this rule. Everything else, the answer is 1. Does that make sense? Okay. Let's get this out of the way here. So as you could see, I wanted to compare these two. We kind of went over it already. The first answer is going to be what? 2x to the power of 0. What's the answer? 2. Great. And the second one, what's the answer going to be? The difference is the parentheses. This whole thing, the whole thing is to the power of 0. So what's the whole thing answer? What's the answer? 1. There you go. Okay, so I hope we understand that. Parentheses make a difference. Right here, it's just the x that has a power of 0, so that's really a 2 times 1, which gives you 2. Over here, the whole thing is to the power of 0, so the whole thing equals 1. Okay? How about this guy? What's the answer there? 1. Because the whole thing to the power of 0 equals 1. Right? Now, even if you were thinking, well, wait a minute, I could apply rule number 3. Remember, you have parentheses with the exponent on the outside. Oh, I could put this 0 right there on the 23, on the 7, on the 9, on the 3, and you're multiplying. So what are you going to have? You're going to have 23 to the 0 times x to the 0 times y to the 0 times z to the 0. And technically, all of those are 1. So 1 times 1 times 1 times 1 is going to be 1 anyway. So that's a waste of time, right? The bottom line is if you have the whole thing in parentheses to the 0 power, then the whole thing equals 1. And that is rule 5. Super easy. Okay. Let's move on to rule 6. This one is a little tricky, all right? Because there's movement going on, all right? Rule 6, and I hope you guys jot this down. Write down rule 6, and then write down negative exponents must move. Negative exponents must move, bless you, from one side to the other, from the numerator to the denominator or vice versa, and then the exponent will become positive. Okay, so I apologize. I probably shouldn't show you the answer. Let me cover that up. So this is the negative exponent rule. Whenever you see a negative exponent, you got to get that guy and move it to the other side, and it becomes positive. The other side of what? The other side of the fraction. What if you didn't have a fraction? Make a fraction. Put a division bar underneath it and just move it to the other side. Okay? So out of these 3 terms, or these 3 variables, which one has a negative exponent? The x. The x to the negative 3 must move to the other side. So everybody copy it down, circle it, draw an arrow down, and write it down here, x, but make it a positive 3, no longer a negative 3, because when you move it, it changes signs. And you could actually just scratch it out from the top, and there's your final answer. The final answer is, check it out, y to the 5th over x to the 3rd z. Again, you moved it down, the 3 became positive. What's your answer? Y to the 5th, that's up there. X to the 3rd z, there it is. So rule 6 is easy, but you got to practice it. Anytime you see a negative exponent, move it from one side to the other. If you would have seen x to the negative 3 down here, you'd have to move it up, and it would become positive. Y to the negative 5, move it down, it becomes positive, right? If you have a negatives. So wherever you have a negative exponent, get that variable that has a negative exponent, move it to the other side, and it will become positive. Let's take a look at some more examples here. This one might be a little tricky, kind of like the 2x to the 0. 2x to the 0, the answer is not 1, it's actually 2. Right here, you want to grab what has a negative exponent. What's the only thing that has a negative exponent? The x is the only thing that has a negative exponent. The 2 actually has a positive 1 up there. So the only thing that you move is the item with the negative exponent. So we're going to grab this x to the negative 3 and move it to the other side. But that's not a fraction. So what? Put a fraction bar right there and bring that down. Okay? So your new fraction, your answer, will be what stays up on top. The 2 stays up on top, and the x to the negative 3 comes down, and it becomes x to the positive 3, and that's your answer. What do you think? Pretty cool, huh? Anytime you have a negative exponent, grab it, move it to the other side, and you're good. Get that out of the way. Let's try another. Now this one has the whole thing in parentheses with an exponent on the outside. So it's up to you if you want to move the whole thing underneath. And if you did move the whole thing underneath, then there's going to be nothing left up on top, right? Imagine a fraction bar. If you take this whole thing and move it underneath, then your answer is going to have nothing left up on top, but you can't just say nothing. You have to put a 1 when there's nothing left up there. Now, if you move the whole thing to the bottom, it'll be a 2x in parentheses to the positive 3 on the outside of the parentheses. But you see, once you have so many rules like we already have right now, sometimes we have to apply more than one rule. So we just moved the whole thing down to the bottom, and now we need to distribute the outside exponent to the inside. So your final answer will be 1 over 2 to the 3rd x to the 3rd, which is actually 1 over 8x to the 3rd. Make sense? But then again, you didn't have to do it that way. Let me erase this. Look, I'm just going to leave the answer. Maybe instead of moving the whole thing down to the bottom, maybe you guys want to distribute the exponent first. Distribute that negative 3. Negative 3 times the invisible 1, that'll be 2 to the negative 3. Negative 3 times the invisible 1, it'll be x to the negative 3. And then after distributing, you have to move those negative exponents to the other side. So this guy comes down, this guy comes down. There's nothing left up on top, but the 2 becomes 2 to the third on the bottom. The x to the negative 3 becomes x to the positive 3 on the bottom when you move them down, which still gives you that same exact answer as we did previously, right? There's many roads to the same place. So we're going to have a total of 7 rules, and as long as you pick one rule to apply, it doesn't have to be in a certain order. Okay, now of course some paths will be quicker than others, so if you think about which rule to apply, it'll be better for you. Anyways, let's talk about the, before talking about the last rule, let me do one more of this. I apologize. Let me get this out of the way. And here we go. Help me out here. What is the only thing with the negative exponent? This is the only thing that's going to move. Where's it going to move? To the other side, and it's going to become positive. So what doesn't move? I always write what doesn't move. The 2 didn't move, the division bar is still there, the x didn't move. The y goes up, and it becomes positive. And that's it. There's your answer. Negative exponents, move them to the other side, they become positive. Rule number 7, the final rule. Everybody jot down rule 7, and then write down cancel out. We're going to be canceling out terms. Now, what do I mean by cancel out terms? Again, I showed you the answer. I probably shouldn't have. The bottom line is you have x to the third up on top and x to the fifth on the bottom. So up on top, let me show you where this rule came from. Up on top, you have x times x times x. On the bottom, you have x to the fifth, which is x times x times x times x times x. And of course, when you have something identical above, something identical on the bottom, that cancels out, cancels out, cancels out. So there's nothing left up on top, so you put a 1 up there. And there's x times x on the bottom, so x squared is on the bottom. Do you understand that? The canceling rule. How many x's were up on top? 3. How many x's are on the bottom? 5. Cancel 3 x's with 3 x's. There's 2 x's left. That's why there's an x squared left on the bottom. Am I gonna do this? Heck no, because it's a waste of time. All right. So it's just simple. I have how many x's up on top? 3. How many do I have on the bottom? 5. All 3 will cancel with 3 of these. So I'm just going to do this. Since all 3 cancel, I'm going to put a line through the whole thing. And they cancel with 3 of the 5. I only put it through the 5. Because if I cancel 3 and 5, how many are left? 2 on the bottom. So there's my answer. Nothing on top over x squared on the bottom. That's what I show right here. Nothing on top, we put a 1 over x squared on the bottom. Now some of us might be thinking, well, if you said nothing on top, why are you putting a 1 up there, right? Well, the fact is, when there's nothing left up on top, you have to put a 1. When there's nothing left on the bottom, then you don't really need to put a 1. Let's take it to something really, really basic. Let's look at a fraction 4/8, yeah? 4/8. That reduces down to what? 1/2. Now, you could think of this in the canceling rule. Now, what do I mean by that? Like, you could rewrite 4/8 as 4 over 4 times 2, right? And you have a 4 up on top and a 4 on the bottom. So you know that the answer is not 2. The answer is there's nothing left up on top. You have to put a 1 up there over the 2 on the bottom. That's why 4/8 reduces down to 1/2. Does that make sense? So when there's nothing left up on top, you have to put a 1 up there. But what if it were the other way around? 8 divided by 4. What's 8 divided by 4? 2. Do you need to put a 1 on the bottom? You don't need to. Why not? Because 2 divided by 1 is just 2, right? So when there's nothing left on the bottom, when there's nothing left on the bottom, you don't have to put a 1 down there. You could just leave it 2. But when there's nothing left up on top, you have to put a 1. So let's go over some more of these examples. Let's move this out of the way, that out of the way, this out of the way. Here we go. Nice. Look at that. Number 1, what could I cancel? Okay. We could start just with, by looking at that. What is that? That's a fraction. What is that fraction? 2/8. What does that fraction 2/8 reduce down to? if it were just 2 over 8? What does it reduce down to? Come on, guys. 1/4, right? You say 2 divided by 2 is 1. 8 divided by 2 is 4. So 2/8 reduces down to 1/4. Those are actual numbers in an actual fraction. So you reduce it just like normal. But what about the x's? Well, I have 2 x's on the bottom. I have 3 x's up on top. Both x's completely cancel out with 2 of the 3, leaving me 1 left over up on top. When I do that, I want to put a line through the square and the x, because there's no more x's left on the bottom, because both of those x's canceled out with 2 of the 3, leaving me 1 x left up on top. How about the y's? Both y's on the top cancel with both y's of the 5 on the bottom, leaving me 3 left over on the bottom. Are you with me? So how many x's do I have up on top? Just 1 x. You could put the power of 1, but you don't really need to. On the bottom, we have a y to the 3rd left over. So there's my answer. 1x to the 1 over 4y to the 3rd. You don't even need to put the 1 right here or the 1 right there. You could just say that the answer is x over 4y to the 3rd. Let's move on to this bottom one. What could I cancel? Actually, let's look at the numbers first. 4/12. What does 4/12 reduce down to? 1/3. Right? I mean, think about it. You could divide by 4, right? Divide by 4 and you'll get a 1 up there. Divide by 4 and you get a 3 down there, right? Yes? 4 divided by 4 is 1 up on top. 12 divided by 4 is 3 on the bottom. So 4/12 reduces down to 1/3. Okay. What about everything else? Well, there's some x's. This x up here cancels with one of these, right? So this x completely cancels with one of these, leaving you 1x left on the bottom. This 1y on the bottom cancels out with one of these, leaving you 1y up on top. So what do we have left up on top? We already put the 1. Is there any other numbers? Nope, but there's a y to the 1. And we don't really even need to write y to the 1. We could just leave it as y. And on the bottom, we have an x to the 1 left over. X to the 1 left over. Right there. There's no y on the bottom. So our answer is 1y to the 1 over 3x to the 1. Or a better way of writing it would be just y over 3x. Y over 3x is that final answer. So now that we know all of the rules, let's throw some more interesting questions that involve more than 1 or 2 rules. Okay, so I just made this question up right here, and there's 3 rules that we could apply, actually probably more. What rule do you see that we could apply? And you don't have to give me the number, but just tell me, oh, I see, what? What do you see up there? You see a what? A what?
Rule 6.
Rule 6, okay, what is that rule?
Negative exponent.
Negative exponents. Okay, so if you see negative exponents, you could grab it and move it to the other side, right? So other side of what? Well, make it a fraction, and you could grab this and move it to the other side and have an x to the positive 7 down here, and you no longer have it up there. And then what? What other rule do you see? Okay, forget the rule. Like, tell me what you see. Do you see a negative exponent? Do you see power of 0? The power of 0, right? Okay, power of 0. So what do we do with the power of 0? That becomes what? Becomes 1, correct? Now, the 4 does not have the power of 0. Just the x to the 0 has a power of 0. So this becomes 1, and you could just scratch it out. Now, why could I just scratch it out? Because 4 times 1 is 4. You don't need the 1 right there, right? So whenever you see anything to the power of 0, you could scratch it out. So that disappears. What other rule do you see? What other rule do you see that you could apply here? We did the power of 0. We did the negative exponent that moved down. Don't we have x to the 5th and x to the 7th? Can't we cancel some stuff out right here? Yeah. What could we cancel up on top and what could we cancel on the bottom? How many x's could we cancel with how many x's? All 5 x's cancel with 5 of the 7, leaving you 2 left over on the bottom. Does that make sense? Now it's getting really messy because I have scratches and circles and all this stuff, right? So let me rewrite what I have. It's a fraction. Up on top, what's left? I have a 2 times 3 times 4. These are regular numbers. So it's actually multiplying. What's 2 times 3? Times 4? 24. Okay. And there are no x's, right? Everything's gone. On the bottom, what do we have left? An x squared. X squared. So there's our final answer, 24 over x squared. Was that the quickest way? Probably not. For example, let's go back to the original question, okay? The original question in black. And if I said, let's rearrange it. 2 times 3 times 4. And what about x to the 5th times x to the negative 7th times x to the 0? Rule 1 says that you could add the exponents, right? So you could have said 5 plus negative 7. What's 5 plus negative 7? Negative 2. What's negative 2 plus 0? Negative 2. So I really, when I add them, I end up with x to the negative 2. Right? And then you have to apply the other rule with negative exponents, move it underneath this. So you're going to have the x to the positive 2 down here. That disappears. And you really have 2 times 3 times 4, which is 24 over x squared. Same thing, just done a little differently. Okay? So we have a bunch of different rules. It doesn't matter which rule you pick. You might pick rule 1. You might pick rule of negative exponents, moving them to the other side. You might pick, the rule of anything to the 0 power equals 1. But as long as you're picking a rule and following that rule, and then moving on to other rules, you should get to the same final answer that should be correct. Yay? Okay.